Okay, in this next installation, we're going to talk about the JSON. We can't really create a persistent inventory system if we don't have a way to take our data out of our game and pass it to our database. And so JSON is the format, the file format you use 9 times out of 10 for transferring data to and from a database server. So let's talk a little bit about how to use JSON in a Unreal project. So first, let's look at JSON. So the JSON file is basically a human readable version of your data. And so if you look at the right-hand side of the screen, it's very clear and evident what the data package contains. And I've done some indentation. You don't need to indent. You can actually strip all of the human readable elements out of it and just have one big long string. But essentially, a JSON is a text file or a string of values in a specific format that the sender and the receivers agree upon. And so in this case, this is the data payload that we're going to be using in our inventory persistence components. And we'll take a few seconds to talk about the structure as we go through, but basically know that there are sort of an array of rows that have some values and then an inset array of the items that are in our inventory here. When we use an API, so in our example, we're using the OWS API structures for data persistence, and we call any one of these APIs. We start to interact with the JSON files. So for an example, if we were going to ask this API get custom data, we have to give it some more information. And so when we issue the post to API character get custom data, we send it a character name and then a value, and this is in a JSON format. So the very simple JSON of open bracket, close bracket, quotes around the name in camel case. We'll talk about that in a minute. And then the actual value here in quotes because it's a string. So when we issue that API call with this particular JSON, the response back we get when we get a successful response is also a JSON string. So here you see the response back, which says, okay, you asked me for some information, and I'm going to go ahead and send you this information back. And so you can see the rows, the customer, whether or not what the character ID is, what the character field is, and then what field value is, which is basically a string. You can see here our human readable termination codes, which we're going to take out in our final version, but it helps us debug when we can copy and paste that into a text editor and see the indentation. So this is also a JSON object. All right, so now let's come back to our JSON package and how we might map that to basically structs and arrays. So if you look at the right-hand side, and I tend to think of things from the inside outward, we have our items, which is an array, as denoted by these square brackets here, of these 5 fields: item definition class, stack count, in storage, skill activated status, and ability slot tag. And so those 5 items, this is item number 1, this is item number 2, this is item number 3. So there are 3 items that are contained within a field value, which is part of a bigger package. So if you go from the item package, those are all contained within field value. In addition to field value, you have your custom field name, your character, your character data ID, and your customer GUID. Those are all in a field called rows. So we have an inset array inside the rows array, which can repeat multiple versions of this entire block. So an important thing to note is that JSON, if you notice, all the first letters in the JSON package are lowercase, followed by uppercase in every second or every subsequent word. And that's known as camel casing. One thing to understand is that the Unreal conversion tools, which let's go back. So camel casing is this structure, a way of naming conventions. Pascal casing is with a capital in the front and a capital in every other word. And then there's a thing called snake casing where you use a dash in between, and you may have seen all of these in various codes. Unreal defaults to Pascal casing, right? That's the standard. When you define anything, you typically are defining your variables in Pascal case. At least that's the norm, that's the practice. And JSON defaults to camel case. The converter, when you try to convert from a JSON to a struct, it actually converts for you from camel casing to Pascal casing. So when you're naming your structs, we want to make sure that the field values match the field values in the JSON, but with Pascal casing instead of camel casing. So you'll note here, stat count is capital S, capital C versus small s, capital C. And so what we've done here is our structs match up, although this is camel casing and this is Pascal casing. You'll see here that I've got a struct defined for my item, which is the fields, right? Item definition, stat count, storage, etc. So 1, 2, 3, 4, 5. And I've called that just persistent item received data. Then I make a T array of this struct and I call it items. And so I've mirrored this structure by saying I have a T array called items. It is made up of these 5 fields so that when you parse this JSON file, follow that pattern. I then have 2 more structs that match the top of the chain. All right. So remember, items are contained within field value. So I made a choice here where, for demonstration purposes and for debugging, I'm actually not going to unpack the field value. I'm going to leave it as a string. But I could have just as easily said, okay, field value is of this persistent field value received data, which would have meant, if I back up a page, it would have looked like this, right? So this particular struct here with items in it, I could have placed here and had it nest the second array automatically. Instead, I've left this as a string. And then I have all the other fields, right? So the custom name field, character, do it, all these fields match up here. That struct is in another T array called rows. So that matches with rows. So that sets up the data structures or the structs to match our JSON payload that we expect back from our API. So when we call our API, that payload is returned. We take that payload and we process it into these structs. So the JSON converter, so the FJSON object converter class provides a couple of different ways to convert JSON to largely structs. So in this case, you'll see, as I said, we're doing 2 steps. The first step is I'm going to use a JSON object to struct, which is going to convert all of the data, but keeping the field values as a string. And so we're using the JSON object to usestruct, passing it in a type, passing in the JSON object that we have defined, and it'll return back to the received inventory struct the data upon success. If that was successful, and then I'm using the JSON object string. So there's a slight difference between this signature and this signature. I'm then going to use the string to pull my field values, right, out of an actual string. So I create the JSON string by taking the field value, the string that was in my received inventory. I just, for readability, just make a new variable here for that. Pass that variable in to the function. The function knows that it's a string coming in this time instead of an object, and it's going to convert that to my usestruct, right, which it gets right here from this field values which is of a persistent field value received data type. Right? So the two-step method is I left the inner array as a string so that I could show you how to take a string and then parse it out as well. So if you are planning to follow along and do this, there's a couple of little things to know around your C++ files. So first, in your build, in your module rules, you're going to need to include JSON and JSON utilities. So those are the modules that you should include in order to make sure your code will compile and link properly. There's two primary include files. One is the JSON object converter. This is the more advanced component. And then JSON serializer, which basically allows you to serialize and deserialize. So if you see down here on the bottom, the JSON serializer has a method for deserialization and a method for serialization. So this is the signature of that. It basically will take that text string and convert it into another text string, a more formatted one. So serializer we don't use a lot. It's better for low-level stuff, but it's good to know that you have two options. The two that we use the most out of the object converter is, so if you do the fjson object converter and then type JSON, you'll see the first couple entries are the JSON array string to a ustruct, the JSON array, no string to a uObject, attributes object string to ustruct, that's the one we're using, and object to ustruct, that's the other one we're using. On the reverse, you have the so these take the JSON and make the uObject. These take the uObject and make the JSON. So these are the in and out versions of those functions. So hopefully that helps explain it. Now let's jump into the editor. So now that we have a better understanding of JSON and the C++ library that Unreal provides for us to use, why don't we go ahead and attempt to make a blueprint function library that exposes some of those to Blueprint. So if you're not comfortable in C++ for the vast majority of your work, this is a way where you can create a library and just put the ufunction wrapper around the calls that you need from C++ and expose it to Blueprint. So what we end up doing is we're back in the editor. So under Tools, we're going to create a new C++ class, all classes, and we're just going to search for Blueprint function library. We're going to select that. This is the base class, Blueprint function library. We're going to call this JSON function library. And because we have plugins and game features running, we want to make sure we stick it in the right plugin. So I'm going to put mine in my Shooter Core Plus runtime. So I have a JSON function library that inherits from the base class of Blueprint function library, and I'm storing it in the Shooter Core Plus runtime directory structure. So I'll go ahead and create that class. All right, so we have our brand new files. Let me shut these down. We have our header file, which is now our uJSON function library, inheriting from our Blueprint function library. And we have our C++, which includes the header. So the first thing we want to do is go make sure we get the include for the JSON library we want to use. So I simply just Google Unreal JSON converter include. That will bring this link to the JSON object converter. If you go to that page, Unreal gives you the include file to include. You see that it's in the JSON utilities module. So you have to make sure that module is added to your build file, and then here's the include file to include. So we're just going to take that, copy it, put it in our C++ file, and we now have access to those functions. We'd have to double check that our build file here and I already have the JSON utilities already in my build file. So we should be good to go to start writing our own function. We want to make sure it's public. Create a U function. We make it blueprint callable, since we want to have execution pins on this one instead of pure. And then we need to make our function. So the best way to make our function, let's go back here. And we're going to say we want to make a function to convert the object string to a U struct. And so you can see the parameters here that we need to pass through. So what we'll do is just copy that. So bool is the return value. Let us call it, can't call it the exact same name. How about the word convert? And we need to pass it a string, the out struct, which is where the results go into, and then our two flags, which we can go ahead and default to 0 right here in the declaration. Okay. Struct type. Go back. All right, so now what we're going to do is do a, I believe it's Alt Enter. Yeah, Alt Enter, and then you can automatically create this signature. And in the C file, it's taken this string, put the name in front of it, and basically copied the parameter sets over. Because we have to have a bool, it automatically puts a return in it. And yes, it's created with my module name here in the header file. You want to make sure that your module name is there so that when you link it with others, it will show up. So at this point, other than this error, which we'll fix in a minute, we can go ahead and just pass these things through. So back to the call function, which is the easiest way to do it. I'm going to copy that again and paste it here. And so we're going to return whatever this function passes us. And we're going to pass it our JSON string, our out struct, our check flags, and our skip flags. So that's calling the, oh, we need one more thing. We need to do the F JSON converter. That's not right. This is what we want. So this now calls this function, passes the variables through it. And that's the basics of how we might use a function library to make a brand new function here that is now blueprint callable, and just wrap this particular function so that we can now in Blueprint do convert JSON object string to usestruct. Okay, sometimes what you think might just be a simple example takes you down a rat hole. And after about an hour of trying different parameter combinations to get the result I wanted to, I realized I was so far off track of what I was recording the video for that I thought I'd simplify it and come back. So where we left off is we had created our Blueprint function library, and we were attempting to create a function that would then call the actual JSON conversion routine, but expose that through Blueprint callable. And so I ended up simplifying to these two examples. And the challenge with these two examples is I'm hard coding the actual item structure in part of the parameter list. That's because a Blueprint callable and a template version of a C++ don't work well together. And so one of the things, if you look at the declaration, yes. So these are templated functions in that you can pass any structure you want in the open and close brackets. So for example, here I'm passing the open and close template that I want to use, and therefore this function will be templatized to this and return in this item structure, which is of the same type. So this is a sort of a fixed type to type. Just going quickly, because these C++ codes use the template function. I went down a rat hole of looking at various examples. So maybe let's go to the editor. So here's our two functions that are part of our JSON function library. So if I were to now type JSON, I would get our functions that we just defined here, these two. They expect a very specific struct to create the string, or the string and it creates a very specific struct. Those are the parameter matchings here and here. Unfortunately, so then I went exploring, so let's keep going. But there are lots of nodes that here I can make a struct. And this is called a wildcard, which is, it's not defined until I connect my struct up to it. So I was going down a path of, well, that would be a better implementation. Also in the getActor class, when you select what actor you're searching for, your output actors are of that type. So the type, the response type, is dependent upon whatever you've selected here. So I went looking at those to see if I could find a quick and easy solution. And the way the gameplay message system worked is they basically defined this wildcard version of the function, and they have this constant integer here, and then they do an override to execute it. So it ends up looking like this, where this function never gets called, but the real function gets called here. And I realized I was starting to go down a path where things were getting complicated. Same with the get all actors, in that the get all actors uses a meta tag, determine output type, which says depending on which of these input variables, so I was trying the struct type here, change the output parameter, which was here, to that type. So trying to follow that example as well. None of these were working the way I wanted it to. They were getting more and more complicated. And so for the purpose of this video, you can see my various failed attempts here of getting the right inputs and outputs in a more utilitarian function. So for this demonstration purposes, or to wrap up this video, you could, as long as you're passing in the structure and out of the structure, you can have as many of these simple helper functions as you need. Again, the purpose of the video was not to talk about creating complex blueprint nodes. It was more to talk about JSON. So after going for an hour on that, I came back and said, you know what, let's just do these two simple routines. So here we would pass in our item struct. So we could do a make off of that. Whatever that struct is, and then the output of this would be our string. Same thing, we put in our JSON string here, and we get out our output structure on this side. So wrapping that up, basically the conversion functions are simply returning the item structs, the JSONs, and the success flags based on calling this function.